welcome to the workshop for one more example on choosing a test to determine convergence or divergence. So at this point we have 10 tests for convergence or divergence. Those tests are the nth term test, geometric series, let's see here, a telescoping series, and then we have a p-series or the integral test, and we have the direct comparison, the limit comparison, alternating series, ratio test, and root test. All right, so that's our 10 tests. And we would like to use each of those tests once on these 10 examples that we have. So what I'd like you to do is I'd like you to pause the video in just a moment to look at all of them and determine for yourselves which ones you think you might use on which test, or which test on which series. Now, there are possibly different answers, so if they differ from what we discuss after you've already taken a guess, then that might be okay. Just make sure you have appropriate justifications. So I'll step out of the way and take a moment to try to determine which test to use. All right. Hopefully you paused the video and took your time. Otherwise, feel free to rewind and pause again. There's a couple different approaches that we could take here. We can go through each series and choose a test, or we can go through each test and choose a series. I think that what we'll do in this case is we'll go through each test and choose a series, mostly because I know what's coming, so I know what not to choose when multiple tests could be used. So your approach may have been different. Let's see here. It's a good idea to check which tests will work for others as well. So for this one, if we start at A, we see that it has a -2 raised to a power. So we should recognize that that gives us an alternating series. So it would suggest that we want to use the alternating series test. But do we have any others that would work on maybe better? So we have alternating series, alternating series, alternating series. Let's see, on this one, after a moment's glance, you might notice that the alternating series is inconclusive or does not tell us convergence. And then for this one, which is an alternating series, this is kind of messy and kind of hard to look at in terms of the n factorial over 1 times 3 times 5 times 7. So let's just say, all right, let's use the alternating test here. Awesome. For the next series, we have 2 divided by 4n squared minus 1. Now, there are definitely some choices that we could make for a limit comparison or a direct comparison. But there are a lot of those that look good here. So let's say to ourselves, what else could we use here? Well, we could use a telescoping series, or recognize it as a telescoping series. And none of the other ones do we have that ability. So we can observe this one as a telescoping series. All right. As I mentioned on the previous one, we could have used the limit comparison or direct comparison, but there are many that we could use that on. And one of those is right here. So with 1 over 2 plus 3 to the n, if I were to decrease the denominator by subtracting 2, I would increase the overall fraction and find something that definitely converges. So I could use the direct comparison in this case. For the next example, we have a number raised to a power. R raised to the nth power, right? This number, sine of 1, happens to be less than 1. So this is actually a geometric series. Of course, it wouldn't be a bad idea to double check in other places if there were another geometric series, because you can use the integral test for geometric series as well when that r is positive. speaking of the integral test, with 1 over n times the natural log of n, it has all positive terms as long as you go beyond 3. So this could work for the integral test. Excellent. For our next example, we have 1 over n raised to the nth power. So it's 1 over n raised to the nth power. Of course, if you take the nth root, then we have 1 over n, which is easy to work with, so we could use the root test here. Excellent. For our next example, we looked at this a little while ago, talking about the alternating series, and we said that if we take a moment to look at it, we would notice the alternating series doesn't apply. And the issue here is that when we ignore, it looks like I'm missing an n here, negative 1 to the nth power, negative 1 to the nth power times 2n plus 3. If we ignore the negative 1 here, this is just first degree poly over second degree poly, which is going to give us something that does not go to 0. So we can use the nth term test on this one. All right. Anytime we see factorials, we can almost immediately say to ourselves that we should use the ratio test. So I'm going to say that for this one. For our next example, if we were to write this denominator using exponents instead of radicals, we would notice that we have a p-series. And for this last example, by a process of elimination, we know that we need the limit comparison test. Yes, limit comparison. And while that may not have been immediately obvious if you were just to consider that problem on its own, recognize that if you were to compare it with 1 over n, then you would have the limit, you'd be taking the limit of sine of 1 over n divided by 1 over n, which would be the limit of n times sine of 1 over n. And that's a limit that we should be familiar with. Hopefully each of the justifications and the choices made sense. And again, let me remind you that other choices could be made in many cases. So feel free to use these tests as they're listed, or feel free to use a test that's different. You just need to make sure that the criteria are satisfied for the implementation of the test that you've chosen. All right. Thank you for joining me in the workshop. I will see you guys again soon.